So today's notes, we are talking about the locus definition of a parabola. Now, we've learned a lot about parabolas. We know standard form for a parabola is y equals ax squared plus bx plus c. That's the one we use most often. That's the one you guys are going to be the most used to seeing and using. Another one we used last unit was our vertex form, and that was your y equals a times x minus h squared plus k, where h comma k was your vertex. So we're getting into a third way of being able to write our equation for our parabola, and that's known as the locus definition of a parabola. So what we have to keep in mind is the definition of a circle is the collection of all points equidistant from a given point. So your given point being your center, and then you've got all of the points around it. That's not a very good circle, but you get the idea of it. So parabolas have a similar definition, but it's a little bit more complex. Because with parabolas, it's not just from a fixed point like it is for your circle. With your parabolas, it's a fixed point and a fixed line. So you take the two parts and it creates your parabola in that way. So the locus definition of parabola is what we call this formula. Locus just means given point, or all the points a given distance from something. Like our circle, all the points a given distance from your center. Your parabola will be from a point and a line. So a parabola is known as all of the points equidistant from a fixed point, which we call the focus, and from a fixed line, which we call the directrix. So those are two words you're going to have to get used to, focus and directrix. Focus is the point, directrix is the line. So the equation can be written in two ways. You can write it as x minus h squared equals 4p times y minus k. Again, hk is still your vertex. That doesn't change. They still use the same letters for that. Or what they do is they rearrange the formula like this so that y is on its own. So you get y equals 1 over 4p times x minus h squared plus your k. Same formula, just rewritten in a different way. Generally, when we're trying to write our formula, we use this one. That's the one that's most commonly used. So in there, we have a lot of letters. X and y are just like x and y in every other kind of equation that we use. X and y stay there. You need to have x and y in order to be able to write your equation. As I said, h and k, those are still your vertex. That doesn't change. What's new this time is that letter P. What P is, it's the distance between the vertex and the focus and the vertex and the directrix. It's the same distance. So if we look at our picture here, we have a picture of a parabola drawn for us. Here's our little parabola. We all know where your vertex is, right down there. It's your turning point. It's where the graph changes from increasing to decreasing, or in this case, it changes from decreasing to an increasing graph. We all know that. Our new things here is there's our focus. That's our point. And here's your directrix. That's our line. So that's the fixed point and line. So the distance between your focus and your vertex is the same distance between your vertex and your directrix. So what they kind of did, it's like they connected these two things together, and when you do, you get that. And the whole point of this is you can pick any point on your parabola, and it's the same distance from the focus as it is from the directrix. I could pick a point right here, and it'll be the same distance from my focus as it is from my directrix. You pick your vertex. It's the same distance from the focus as it is from the directrix. Any point on that parabola is equidistant between those two things. So let's take a look at some questions. We have the parabola y equals 1/4 x squared plus 1 is shown graphed below with the selected points shown. For this parabola, its focus is the point 0, 2, and the directrix is the x-axis. Okay, so we've gotten a lot of information so far. They've even drawn our focus in here. Here's your directrix, which is your x-axis. Remember, we write this as the equation y equals 0. And then they pick some points here along the parabola. So they want to know how far is the turning point, 0, 1, from both the focus and the directrix. And then they want to know how far is the point 2, 2 from both. Okay, so let's do the first part. Let's start with the turning point. So if I go over here, I mean, this one's easy to count. Here's my turning point. It's 1 unit from the focus. If I go the other way, it's 1 unit from the directrix. So the turning point is 1 unit. They want us to do now the point 2, 2. The point 2, 2, right here. I can easily count. It's 1, 2 from the focus and 1, 2 from my directrix. So it's 2 units from both. And that's what's going to happen every single time. So B, verify that the point 45 is the same distance away from the focus and the directrix. Okay, so focus, directrix. We may have to do some calculations here. Well, let's take a look at our graph. So here's our point 45. I can easily count it to the directrix. It's 1, 2, 3, 4, 5 units from the directrix. 5 units. Though if I'm going from the focus here, it's not so easy to count. That's a diagonal line. I can't count boxes like I did for the directrix there. So what I need to do is I'm going to create a right triangle here. So that's 1, 2, 3, 4 units for my base. 1, 2, 3. 3 units for my height. So one way I can figure this out is by doing the Pythagorean theorem. And that will give me my distance from my focus, this side right here, my x. So that would give me 9 plus 16 equals x squared. So 25 equals x squared. Take the square root. And we get x equals 5. So see, it is the same distance from both the focus and the directrix. The other way we could have done it here for our focus is this is a triple. A 3, 4, 5 triple. So you could have known it that way also, that the distance would have been 5. But either way, we have now verified that the distance from both is the same. 2. Consider a parabola whose focus is the point 0, 7 and whose directrix is the line y equals 7. Y equals 3. Sketch a diagram of the parabola below and identify its turning point. All right, so I'm going to sketch in there an x and y axis. So our focus is the point 0, 7. 1, 2, 3, 4, 5, 6, 7. So it's right there on our y-axis. Our directrix is the line y equals 3. So that's a horizontal line going through your y-axis at y, where y is 3. So there's our directrix. So based on our definition that we know, our turning point has to be in the middle of that. So in the middle of 3 and 7 would be right there at 5. That's our turning point. So sketch the diagram below and identify its turning point. So we will write turning point is the point 0, 5. And then part B, determine the equation of the parabola using the locus definition. So keeping in mind our locus definition is 1 over 4p x minus h squared plus k. So we need to know those 3 things. Based on my turning point over here, I have my h and my k. My p, remember, that's the distance from the focus to the turning point and the turning point to the directrix. So if you count that, our p is a 2. So we're going to go ahead and plug that into our formula. So we get 1 over 4 times 2, and then x minus 0 squared plus 5. So I'm just cleaning this up a little bit. 4 times 2 gives me an 8. X minus 0 would just be an x, and then our plus 5. So there's our locus definition of a parabola. It's not so bad. So I find the picture on that one helps. Okay, 3. Determine the equation of a parabola whose focus is the point 4, 1, and whose directrix is the horizontal line y equals negative 3. So again, to help me figure this out, I'm going to sketch myself a picture. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I'm going to plot my focus first. So I got point 4, 1, 1, 2, 3, 4, up 1. My directrix is the line y equals negative 3. So they want us again to determine the equation. So first thing I need to figure out is, where is my turning point going to be? So if you noticed in all of our other pictures, well, this one picture we drew, they all lined up. Your turning point was directly under your focus and directly above your directrix, which it's easy to be above your directrix. It's an entire line. It's this whole thing here. So really it can be anywhere above that. But it really, the key thing is it needs to line up underneath your focus. So if we count here, we have 1, 2, 3, 4 units in between the directrix and the focus. So your turning point is going to be in the middle of that. So your turning point is going to be right there at the point 4, negative 1. So I'm going to write myself a note here. Turning point is 4, negative 1. And again, I need to know the value of P, which is the distance between my turning point and my focus, and my turning point and my directrix, which again for this example would be a 2. So then using our definition, 1 over 4p times x minus h squared plus k. So we'll plug in 1 over 4 times 2, x minus 4 squared minus 1. So just cleaning that up a little bit to get our final answer, it would be y equals 1/8 x minus 4 squared minus 1. And there's our locus definition. Okay, and then number 4, find the vertex, axis of symmetry, equation of the directrix, and the focus for this given equation here, which this is in locus definition. This is just the form that's not as commonly used. It was that first form that I showed you on the first page. So what I'm going to do is I'm going to make myself a little list here. I need to know the vertex. I need to know the axis of symmetry. I need to find the directrix. And I need to find the focus. Okay, so there's my list. What I'm going to do is I'm going to rearrange this so that it looks more like that equation. So to do so, I'm going to divide by 4. So I get 1/4 x minus 3 squared equals y plus 2. So then I'm going to subtract my 2. And I get 1/4 x minus 3 squared minus 2 equals y. Okay. So from here, I can find my vertex, h, k. So my vertex is the point 3, negative 2. Now, if you remember from stuff you've done before, your axis of symmetry goes right through your vertex. It's a vertical line, so it's x equals. And so it goes at x equals 3 because it's whatever that x value is from your vertex. So now what we have to figure out is, where is your directrix and where is your focus? If you remember from our definition, that was a 4p. So to figure it out, I take 4p and I set it equal to 4 because that's what my number is there. Divide by 4 and I get that p is 1. So that means our vertex is 1 unit from the focus and 1 unit from the directrix. Since it's a positive 1, that means the focus is above the turning point and the directrix is going to be below the turning point. So that means my focus is at the point 3, negative 1, and my directrix would be the line y equals negative 3.